Good morning and welcome to CABE Webinar Wednesday. Today we're looking at the benefits of natural cement with Jack Edwards, a technical sales manager at Natural Cement. In this webinar, we will explore the benefits, history and many applications of natural cement-based products, including concrete repairs, waterproofing, screeding, grouting and sprayed concrete in a variety of industries. This presentation will also cover the properties, performance, applications and case studies and environmental benefits of natural cement. My name is Shanika and I am the Training and Learning Coordinator here at CABE, and I'll be acting as moderator for this morning's session. We strive to create interactive webinars and we encourage you to submit any questions you may have during the session. These questions will be addressed at the end of the presentation. We will get through as many as possible, but if we do run out of time, we will collect your questions and send the answers out in due course. You can also contact webinars at cbuilde.com. If you're watching us live, you can use the side panel to send in your questions. Alternatively, you can get in touch with us via the social links now on the screen. Let me introduce today's webinar speaker, Jack Edwards. Jack is based in Barnsley, South Yorkshire. His role at Natural Cement involves providing technical support to contractors, distributors, engineers and architects on construction and civil engineering products throughout the UK. Jack has been in the role of at Natural Cement for 7 years now, having spent the previous 10 years working in both manufacturing and contracting with the construction industry. So give me a couple of seconds, I'll just hand over to Jack and he will begin shortly. So Jack, you can now start. So I'll stop sharing my screen.
Okay, thanks, Shanika. Good morning, everybody. That was quite an introduction. But again, my name is Jack Edwards. I'm Sales and Technical Manager for Natural Cement. Just give me 1 second. Hopefully this will work. Okay, so hopefully everybody can now see my screen. So a presentation we've got for you today on the benefits of natural cement, which is pretty self-explanatory in the title, really explains exactly what it is. But this is the format of how I'm going to run through things. I'll start off with a bit of an introduction as to what natural cement is. Then I'll explain sort of what Natural Cement do as a company and activity we get involved with. Then, like I said, the question we get asked all the time is what is a natural cement and what makes that natural as opposed to any other type of cement. Then I'll run through a little bit of history. There's quite a bit of history in there. It gives you an idea of the natural cement industry as a whole and maybe why it's not as well known as it once was. Then I'll run through some of the properties and benefits of the products. I'll explain how they work and why they do what they do. Then I'll run through some applications and case studies, so you can actually see the materials being used in a variety of different scenarios. Hopefully there might be some part in that section which may be relevant to things that you get involved with. And I've got a section on sustainability, which is the hot topic at the moment. It's something that's only getting bigger and bigger for our industry. Bit of a summary, and then time for questions and answers at the end. So probably about sort of 40 to 45 minutes in total, plus time for some questions. So I'll try and keep it interesting as best I can and try and not keep you too long. So to tell you a little bit about Natural Cement as a company, so we're based in Barnsley in South Yorkshire. That's where our head office is. Our manufacturing facility is just down the road in Sheffield. From there, we manufacture products and distribute them all over the UK and internationally as well. Even though we're called Natural Cement, we don't actually sell cement. Natural Cement is a binder that we use to form the basis of all the products. So they're all based on the same Natural Cement binder. That's what gives us all the sort of unique properties, which I'll explain in more detail a little bit later. But predominantly, the range is made up of mortars, grouts, and shotcrete products. So the pre-packaged materials, 25 kilo bag, all the aggregate and everything already pre-blended. That bag arrives on site, mixed with water, and then apply it straight away. In terms of industries we're involved in, construction, obviously, civil engineering is a big one, rail, water, utilities, probably sort of main ones we get involved with. Water and utilities is a big one for us. Once I get into some of the properties of the products and explain how they work and why they do what they do, you'll understand why they maybe lend themselves well to certain applications more than others. But we're not limited to these. We get involved in all sorts of weird and wonderful things. So I'll start off with a question. Like I said, something we get asked all the time is what is a natural cement and what makes that natural as opposed to any other type of cement? Essentially, a natural cement is manufactured from one single source material. So it's a stone that has everything you need to produce the cement without adding anything to it or without taking anything away from it. So during that production process, it's obviously excavated, it's heated, ground to a powder, and then we use all the properties that we get from the natural cement, we get from it naturally. The stone that we use is actually called an argillaceous limestone, which essentially is a limestone that contains clay within it. Obviously, with any other type of cement, with ordinary Portland cement, you still be using limestone as your base, but then you take a combination of different minerals, additives to try and blend that together to make it perform in a certain way. Or with the natural cement, all the properties we get from it, we get from the stone without any other additions after that. And natural cements are nothing new. They've been around for hundreds, if not thousands of years. The Romans were famous for using a lot of natural cements in their construction. What they used to do with when they created their natural cements, they used to use pozzolanic material. They used to use volcanic fly ash, which is a pozzolanic material, which what that does, activates the lime, makes it faster setting, also helps it achieve greater strength. So by adding that to the lime, adding it in stones and sand, they could then create mortars and concretes. But like I said, the pozzolanic material that they used, we use clay, which works in exactly the same way. So the basic theory of, like I said, of using pozzolanic materials with limes has been around for hundreds and thousands of years. It's not hundreds of thousands of years. It's not a new technology. Looking at cement production in this country, in the UK, the guy that you can see on the left, a guy called Reverend James Parker, he found something in and around the Thames, in the Thames estuary, called cement stones, which essentially was a particular type of stone that when it's fired and crushed and ground in a certain way, a cement was produced. So that's obviously, that would again be a natural cement, because during that production process, nothing was added to it and nothing was taken away. So as all good businessmen would, what he did was he patented his product and he marketed it as Roman cement, because there's similarities to the Roman cement, all these previous, which I've just mentioned. Being based in and around the Thames, he was well positioned for moving his product into London, and it became sort of a standard product used across London. A lot of construction around that sort of time period. If you can probably appreciate, in the early 1800s, it was very difficult to move cement around the country. So, like I said, being based in and around the Thames, he was well positioned to move his product into London. Once that patent expired around 1810, mines cropped up all over the UK and internationally as well, trying to replicate what Parker was doing with his Roman cement in London. The thing is, with a natural cement, as I just mentioned, because all the properties essentially are in the stone that you're taking from the ground, is they all perform differently. So depending on the local area, the local geology in that particular area, some would set fast, some would set slow, some would be stronger than others. All the properties will be unique to that particular area. But as I said, mines cropped up not just in the UK, but internationally as well, in Europe, America, Canada, all trying to replicate what he was doing and create their own versions of the natural cements. So throughout the 1800s, natural cement industry became an extensive industry worldwide. Like I said, mines cropped up all over the place, creating their own versions of natural cement. One of the most successful natural cements was a product called Rosendale cement from America. They had 25 mines producing this at one point. And again, similar to Parker being around London, they were based on the outskirts of New York, well positioned to move their product into New York. Well, even back then, there's still a fair amount of construction taking place. It became a standard product for use for construction of roads, bridges, wherever they were building. It tended to be used there. It tended to be their cement that they were using. And a bit of a fact for you. The plinth that that Statue of Liberty stands on is actually made from their natural cement as well. So because of the inconsistencies in the natural cement, as I mentioned, they all perform differently depending on sort of the way the materials are produced and the area that they're produced from. The guy that you can see on the left, a guy called Louis Vicat, what he did was he discovered an alternative way of producing cement. So rather than being reliant on the properties of the one particular stone, he explained the theory of mixing clay and lime to create a manufactured cement, or an artificial lime, as they called it back then. And he actually opened the first artificial lime factory near Paris in around 1818. So although the sort of thought process is very similar to the way that modern cements are produced, taking a combination of different minerals and limestone as your base and blending that together to create a manufactured product, it wasn't until 6 years later that the Portland cement was actually patented. So at the factory, at the Vicat factory in France, they produced both the natural cements and the Portland type cements, or the artificial limes as they call them, side by side. They were sold for different purposes and used for different applications, with the natural cement always sort of being the premium product, as it outperformed the artificial limes for almost 50 years in terms of strengths and setting times and performance. It wasn't until towards the end of the 19th century in the way they made big changes in the way that cement's produced. One is they introduced rotary kilns, which you can see on the left, and the other change they made was they also massively ramped up the temperature, which meant they could use a wider variety of limestone, because essentially the higher temperature is burning away a lot of the impurities in the stone. So what that resulted in was production of a much better quality product, which is produced at a much lower cost, because, like I said, that massive increase in temperature burning away a lot of the rubbish and the impurities that you don't need, and you're left with a much better performing product. So it doesn't matter what sort of business you apply that to, really. If you can produce a better quality product at a lower cost, then obviously you're winning. What this resulted in was the decline in the use of natural cements for obvious reasons. One of the biggest sort of factors, really, in the demise of natural cements, if you like, or the reduction in usage, was the inconsistencies. If you were an architect or an engineer around that sort of time period, specifying a natural cement to be used on a particular project, you couldn't really guarantee the performance, because it would depend on the mine that it was taken from. Some would set fast, some would set slow. Like I said earlier, some would be stronger than others. All the properties will be unique to that particular local area. All of a sudden, you've got a manufactured type product. You can specify the exact sort of material and guarantee the performance that you need. Obviously, around this, in the meantime, sort of they've invented trains, so they can actually not specify the material. They can actually get it to the site where they wanted to use it as well. So, like I said, all these factors combined resulted in a decline in the use of natural cement. So it got sort of overtaken by the artificial or Portland type cement industry. It wasn't until the engineers was designing the underground rail network in France when natural cement was sort of rediscovered, if you like. It was actually the need for high early strengths in the sprayed concrete linings that they were using on the underground tunnels, which sparked the revived interest. And then what they actually did was they modernise the plant, modernise the production facility specifically to supply that project. Fast forward to today, and that's the same natural cement that's produced, bring to the UK and used to form the basis of all our products. Excuse me. So, like I said, it's quite a little bit of history, but hopefully it gives you a picture of the natural cement industry as a whole, and maybe understand why it's not as well known as it once was. So, just to run through, like I said, the natural cement that we produce and use to form the basis of all our products, it's still produced en masse today. It's fired in traditional vertical lime kilns. It's fired between 600 and 800 degrees, which is a much lower temperature than ordinary Portland cement, which gives a quite a large reduction in carbon footprint, which I'll touch on a little bit later. But generally, in terms of performance, a much faster setting with greater rapid hardening than the early natural cements, and strength very similar to those of modern Portland cements. The seam limestone that it's taken from, it's very stable, it's very consistent. Obviously, they've been producing it for over 150 years. But technically, because it is a natural resource, there's only a finite amount of it available. It's estimated at current usage, you've got around 500 years worth of supply left. So I don't think we're going to run out any time in the near future, unless sales figures go through the roof in the next few years. But that's not to say they couldn't open a seam up in the next mountain. It could perform exactly the same, or it could perform totally different, like I said, because they're completely reliant on the properties that they're taking from the ground. Once I get into some sort of product names, you mentioned the word NatSem. That's predominantly what the market the product has in the UK, as you can see from the pictures on the left. And also at the bottom line there, you can see the CE marking that the products carry. They're actually in the process of converting that to a UK CE marking at the moment. So now I'm going to run through some of the sort of properties and benefits of the natural cements. The majority of properties that I'm running through in the next few slides would only be usually achievable in a cement or concrete-based product by using a variety of different additives to make it perform in a certain way. All the properties that I'm running through now we get from the natural cement naturally without the need to add anything to it. So the first thing being, you've got a very, very fast set. So the cement itself, once it's been produced, once that's been ground to a powder, if you were to mix that with water, it will set in around 90 seconds to 2 minutes. So it's very, very, very fast setting. That's not an accelerated setting time. That's just its natural setting time. Excuse me. And I know I just said we don't add any additives into the equation, but the only one thing we do add is a retarder to delay that set to achieve a more workable mix. So we've got a product called Water Stop, which is a plug for sealing against active leaks. So for instance, if you're in a below ground scenario, you've got water penetrating, you mix that into a putty, hold it in place for 90 seconds, and then the leak would be sealed. Obviously, realistically, beyond that, when the material is set in 90 seconds, you can't do much else with it. So the one thing we do add is a retarder to delay that set and achieve a more workable mix. The retarder that we use is another natural product. It's citric acid. Essentially, it's powdered lemon juice, another completely natural product. By adding that during manufacture, we can delay the set to whatever we want it to be. But that being said, the most of the material set sort of within 45 minutes to an hour, so they're all still fairly fast setting. As well as setting very fast, they also get strong very quickly. They've got very high early compressive strengths and high ultimate compressive strengths. Again, I'll touch on that a little bit later. But it's these two properties really, the fast setting and the high strengths, early strengths, that the products lend themselves well to repair work and remedial work, or potentially areas where you want to get something done quickly and get put back into services as soon as possible. The cement itself, it also has natural waterproofing properties, so it can be used for both positive and negative water pressure. So that's either keeping water in structures or keeping water out. Again, I'll touch on that a little bit more detail later. It also sets underwater. It has anti-washout properties, so essentially it will perform exactly the same underwater as it will out of water. And it also has a high chemical resistance, mainly being sulfates, chlorides, and nitrates. So it's suitable for use in quite a sort of harsh aggressive chemical environments. If you look to the picture on the left, just to give you an example of that, you can see the guy is carrying out some repairs to a seawall. Obviously, it's in a tidal area. Because the materials set very fast and they get strong very quickly, perfect for installation between changing tides. It can be waves crashing against it just a couple of hours after it's been installed. It's going to be strong enough to hold it in place. Then, obviously, on top of that, it's resistant to the sulfates and nitrates. It's the sulfates and the chlorides that you're going to be getting in the seawater in the sort of harsh chemical environment as well. A few more properties. So the cement itself, it has excellent adhesion, so it'll bond to pretty much anything as long as you've got a nice rough surface to give it a mechanical key to adhere to. In terms of sort of preparation, usually we recommend just using water and dampen it down before application. In terms of alkalinity, because the material has a high alkalinity, and one of the big differences in the chemistry between natural cements and Portland cements is the amount of free lime. With the natural cement, once the material's been mixed with water, all the free lime is used up in that chemical reaction. And it's when the free lime leaches out of concrete, which when the pH can drop, it can use its ability to prevent any corrosion of any reinforcement. With the natural cement, because there's no free lime, so the pH doesn't drop, so the pH remains at a certain level, which means if it's got any embedded reinforcement, it wouldn't need to be primed. As long as it was fully encapsulated in the natural cement, it would prevent it from corroding. So we've got some examples in France casting something like 1850, which have got reinforcement, casting natural cement, which is still showing no signs of corrosion today. Last part on this slide, which is probably one of the biggest unique selling points to the materials, really is probably one of the biggest differences in natural cements and any other type of cementitious product, is the fact that it doesn't require a curing period. So with any sort of cement or concrete, you've usually got a period of initial setting time, so a period of the product firming up. Then that'll be followed by a period of cure, so where certain chemical reactions are taking place. Then that'll be followed by a period of strength gain over the days and weeks and months, so the material's getting stronger and stronger and stronger. With the natural cement, once that material's set, it's fully cured. So in sort of real terms, what that means is it can be overcoated, it can be painted, it can be plastered as soon as 1 hour after the initial setting time. All it will do then after that period is continue to gain strength. So just to give you an example of that, if you look at the picture on the left, you can see the guys in like a screened area to a car park entrance. Once they got to the end, clean down the tools, they could put the final finishings over that in the same day without having to wait for any sort of 28-day curing period before they can get on top of that material. So again, I'll touch on that in a little bit more detail a little bit later. But last slide on the properties. So ideal sort of this time of year in the cold weather, the materials can be used down to and below 0 degrees. The lowest we've been used successfully is around -15 degrees, but generally speaking, the general working temperatures are 0 degrees and rising. I just mentioned about the free lime in particular being used up in the chemical reaction. Also, all the free water is used up in the chemical reaction, which is why we can use the products down to and below 0 and in freezing temperatures. The products are also safe for use for potable water. So we've got 6 different products, which are DUI Reg 31 for direct contact with potable water. We've also, the materials have no shelf life and no contaminated waste. So if you look at any of the bags of material, it'll have a batch number, which references the manufacture date. But if you look for any of the literature, I recommend using sort of within in around 12 months, but there's actually no limited shelf life. So as long as the materials were kept in decent dry conditions, it would actually save for years and years and years if need be. Then also on the no contaminated waste, because there's no chemical additives in the product, any waste that's left over can either be recycled or reused without any issues and without any need for sort of specialist waste bins or specialist contaminated landfill or things like that as well. The materials you use, 1 component system, mix powdered water for 2 minutes and apply it. Very, very straightforward products to use. And then last part on this slide, the carbon footprint, which I did mention a little bit earlier. So the carbon footprint is generally around 30% lower than it is modern Portland cements. So that's due to the much lower temperature that the materials are fired at during production. But again, I'll touch on that in a little bit more detail later. So just to touch on some of the strength characteristics of natural cements. So I did mention earlier that the strengths are very similar to those of more important cements. If you look at the test, the results that are on the left here, this was some test done a few years ago now, and basically it's on a mixture of natural cement, sand, and retarder. So you can see that after 3 hours, the material's got 9 MPa compressive strength. So as I mentioned, they get strong very, very quickly. After 28 days, you can see they've got 51 MPa compressive strength, which is pretty standard, really, in most sort of high strength cements and concretes. It's nothing out of the ordinary. But actually, if you look past that period, if you look to 3 months and 6 months and a year, you can see after 12 months, the strength's gone up almost 50% as to what it was at 28 days. So one of the sort of unique properties of natural cement is the fact that the longer it's in place, it will continually gain strength forever. It will never ever stop gaining strength. So as long as the preparation is done correctly in the first place, the mixing is done correctly in the first place, and the materials are installed correctly, all that material will continue to do is gain strength forever with no upper limit. A little bit more on test data. I'm not going to all this in too much detail. It's not the most exciting stuff, but this is all available to download on our website. All the testing that's on there is done all externally verified testing. But on there, you can find some tests that were done by a BRE on brownfield sites and different contaminants that are found in the ground and different sort of chemicals and the effects they have on natural cements. Details on carbon dioxide penetration, water permeability, but pull-out tests, etc., etc. So it's all available to download on our website. So I ran through a bit the sort of history of natural cements. I've explained the production process. I ran through the properties, explained how the products work and why they do what they do. It's usually at this point where people sort of think, especially if I do this presentation for a lot of people fairly often that have never heard of natural cement, I think if it's this wonder product, why can't we just use it for everything if it's so much better than all these other types, all these other products? Obviously, it comes down to cost effective and it comes down to practicality. Often when the materials are setting very quickly, they're not it's not always practical to be used for everything. So the applications that we're running through now are the ones that materials tend to get used more often than not, and where we tend to get it has sort of more advantage over a lot of modern alternatives. The first one being concrete repairs. This can be any sort of structural or cosmetic repairs, both vertical, horizontal, or overhead repairs. A lot of sort of bridge structures, sea defence areas, potable water structures, anywhere where you've got existing deteriorating concrete needs to be brought back to life. But natural cement products are going to be suitable for doing that and suitable for doing it fairly quickly as well. Waterproofing, so there's a common one. So waterproofing or tanking. The materials, because they've got natural waterproofing properties, as I mentioned, they're ideal for anywhere where you want to keep water in structures or keep water out. When the materials used for waterproofing, they're prominently used as a render. So if you look at the picture on the left, you can see there the guy rendered one of our products, NatSim 35. They render that onto the floor and walls, 10mm thickness, and a 10mm coating in natural cement render will all back up to 10 bar hydrostatic pressure. So it's pretty strong stuff. Common area you tend to get involved with, obviously on a sort of domestic scale, basements and cellars and vaults and lift pits and areas, any sort of below ground areas and domestic properties where obviously you need to keep water out. Then obviously on the flip side of that, getting involved in a lot of sort of pools and tanks where you obviously keeping water in structures as well. And then on a much larger scale, we also get involved in a lot of sort of tunnels, tunnel linings, and reservoirs as well, where again, with either keeping water in structures or keeping water out, the materials are going to be ideal. Grouting is the common one. So the materials are used for any sort of stabilization or void filling in particular areas. To be honest, natural cement grouts only tend to get used really if you need some of the sort of specific properties that you're getting from the materials. So as in the rapid set and strength gain, or if it's an area where you need something that's going to have a high chemical resistance, it might be coming into contact with certain nasties and certain chemicals. On the flip side of that, if it's an area where you don't want to be introducing any chemicals into the equation, so we get involved in a lot of grouting projects, not just potable water, but generally around sort of water courses and in areas where there could be concerns over contaminants getting out of that grout, getting into the water course and potentially harming the environment around it because the materials are very, very safe to use in those scenarios. So we get involved in a lot of grouting projects in sort of a lot of rivers, canals, like I said, I mentioned potable water, wastewater, marine environments, anything around water, really the materials are ideal. Screeding is another common one. So to be honest, you probably wouldn't use the material as a straightforward alternative to a cheap and cheap or sand and cement screed because one, it'll be quite a bit more expensive. But if it's an area where you need to get on top of it very quickly, if you need a rapid turnaround, All of a sudden, sometimes extra increase in material costs can be far outweighed by the costs that can be saved either on labour or project time or running costs or and things like that as well. Common areas tend to be sort of pools, balconies, like I said, areas where you want to get something done quickly and get back in as quickly as possible. Potable water areas, potable water structures, bunds, tanks, areas like that. But just to give you an example of sort of time savings, as I just mentioned, so if you look at the picture on the left, you see the guys laying a screed over the top of that's actually a bottom of the swimming pool. This was a large hotel development in central London. The contractor had problems with the concrete slab that you can see on the bottom. They needed to put a screed over the top before they could put a liquid waterproofing system. So they used our product, that's M35. You can see the screed in that sort of 30-40 mm thickness over the whole pool, which again, probably would have been cheap to do it over that whole area. But even though that's a waterproofing product in its own right, it was used purely in this scenario because they needed to get something down so they could get on top of it very quickly. The screed of that area on one day, using the M35, you can see that sort of thickness. The day after, they could get straight on top of that with the liquid waterproofing system. Whereas with a standard cement screed in that particular application, you're probably looking at a 28-day curing period before you can then get the moisture content down to get on top of it with a liquid coating. Like I said, with the natural M35, they got on top of it the next day, say 4 weeks of sitting around doing nothing, which obviously massive cost implications, massive cost saving for the contractors. So sometimes with the screen, it's about identifying the applications where you're going to get the benefits of the time savings. And underwater, again, something I did touch on a little bit earlier. The materials essentially perform exactly the same underwater as it will out of water. So we get involved in a lot of sort of underwater concrete repairs, pointing, grouting, any sort of general work in and around water courses. So whether that's clean water, wastewater, marine environments, rivers, canals, anything around water, the materials are going to be ideal. So just giving another example again, if you look at a picture on the left, if you can make it out where you've got the van at the top, the guy's got stood there with a grout pump. If you look on the middle of the water, you see the diver with the yellow helmet on. What he's actually doing, he's diving down, placing one of our products directly underwater. He's actually filling grout bags, pumping it directly into them to some stabilization and work underwater. Once the materials land under the water, it will just sit in place and set in place. It will not leach out. It will not wash away. And also, there's nothing that's going to be escaping out of that grout and eventually potentially harming anything in and around that environment. The materials are pH neutral once set, so that's not going to affect any of the pH of the water course as well, because obviously the last thing they want is to be carrying out any works and a bit further downstream you end up with fish floating down the river. So like I said, very, very safe for using in quite sort of environmentally sensitive applications. Last one on the applications, sprayed concrete. So with sprayed concrete process, there's two ways of doing sprayed concrete. There's a dry spray process and a wet spray process. So with the natural cement products, they're all dry spray application. So because the materials set very fast, as I mentioned, you couldn't really pump anything wet because everything would be blocked up and lines would be blocked in no time. So with the dry spray process, what they're actually doing is they're using air to feed powder directly into this nozzle. They've got where the nozzle, if you can make it out on that picture, they've got another separate area where the water comes in. The materials mix in the nozzle, it flies out and lands on the wall mixed. So with that process, it's ideal for problematic areas which might be difficult for access, sort of larger areas which might be too labour intensive by hand, get involved in lots of sort of tunnels, retaining walls, underpinning, larger scale concrete repairs, or large scale areas of waterproofing as well. A lot of the shotcretes tend to set between sort of 2 and 10 minutes. So what that means, you can build them to any thickness that they've been sprayed at sort of 150, 200 mil hit, 200 mil depth in one hit of that without any issues as well. So if you can actually make out that picture, I know it's not the best picture, it's quite dark, but the guy's actually stood spraying the top of the tunnel. He's actually stood on a boat in a canal. So like I said, perfect for areas which are problematic for access and things like that as well. So obviously the applications, like I said, they're the ones that the products are most commonly used for. They're the ones where we feel they have a lot of benefits of a lot of modern alternatives, but we're not limited to these. We get involved in all sorts of different applications as well. So I'm just going to run through a few different case studies so you can actually see the materials being used in a few different scenarios. The first one, this is a concrete repair project. This was done up in Glasgow probably 3 or 4 years ago now, in the city centre. You can see from the picture on the top left, a lot of the lintels have suffered from corrosion. A lot of them have started to blow. A lot of them started, sort of large areas of cracking and concrete spalling and falling away. This particular project, it was 6 stories high, right in the city centre. So obviously the last thing they wanted was any concrete probably dropping off there and falling onto the public below. So the structural engineer that was involved, once the contractor broke away the defective concrete, which you can see on the bottom left, he specified adding some added reinforcement to give some extra protection. Very, very straightforward method of repair. The contractor put some timber shutters across the front and underneath, which you can see on the centre picture. They use one of our products again, that's M35, makes that like a grout consistency. Pour that into the gap at the top, vibrated the shutter so you got the compaction, and you can see the end result that they got really nice tidy finish on it. And even at that sort of depth, the repair sort of 150, 200 mil depth, there were no issues with striking those shutters off the next day. It was strong enough to hold in place. And then just to get straight on top of it and paint it. Like I said, got a really nice finish on it. With this project as well, the works were carried out in Glasgow through the winter months, sort of November, December, January, so absolutely freezing conditions. So again, perfect for the natural cement products. It meant they could keep the project moving through the winter months without having any delays. A few more examples. Really, of the materials used in around water, which I mentioned. The one on the top left, you can see one of our shotcretes being sprayed in around the Thames. The one on the bottom centre, and the bottom right, which you can see, that was the sewage treatment works in Sheffield. That was the beginning of last year. You can make out a sort of large screeded area around the bottom of these tanks. It delaminated in some areas, so you can see they use one of our products to sort of repair the screeded area. One of the reasons that we used in this particular application was because obviously it's a sewage treatment works, there's all sorts of nasties and not very nice things in that water that the product's going to be coming into contact with, so it needs to be. But also, what the contractor found in this particular project is they were draining the tank down, carrying out the repairs. The day after, it looked like it did on the centre again. It was filling up straight away. So with the natural cement products, perfect for being submersion pretty much straight away after they've been installed. So again, it was the ideal solution for that particular project. Another sprayed concrete project in the centre, that was a network rail project done a couple of years ago now, up in the northwest. The contractor had very limited possession time. They were limited to weekend work until they had possession of the track on a Saturday and a Sunday to carry out repairs to the top of the tunnel, which you can see just doing strengthening work using one of our fibre reinforced shotcretes. They were spraying the repairs Saturday, Sunday, Monday morning trains running through without any issues are strong enough to hold in place. And the one on the top left and the bottom left, you can see, this was a project carried out in sort of middle of last year. This is a good example, really, how sometimes we can get approached by contractors with specific problems, and we can come up with a tailored solution rather than just looking for a sort of off-the-shelf product. So this was some repairs that were carried out on the Scottish Nature Reserve. You can see on the picture on the top left, a lot of the steps are deteriorated. Obviously, there were a lot of public visitors. Obviously, they didn't want anyone falling into the water or any concrete starting to fall in, which you can see. But because it was so the contractor had to repair these steps, but because it was a nature reserve, they weren't allowed to mix any materials actually on the island itself. It's on the Scottish Islander Stafford. There's a full case study on our website if you want to read a bit more detail about it. So they couldn't mix any materials actually on the island. So they had to mix the materials on a boat, transfer them across, pour the repair mortars, and then repeat that process over and over. Obviously, as I mentioned earlier, our product set very fast. So what we actually did was we supplied them a product with some additional retarder and give them a certain ratio, which would extend the working time from 30 minutes to around 90 minutes. Because even though they need a longer working time, once that material's been put in place, you can see the waves right next to it. They need it to go off fairly quickly, so it's going to be strong enough to hold in place. So, like I said, a really nice project, and they actually dyed the materials to like a black to match up with existing stone, which you can see on the bottom left. So, really nice end result in that one, and really, like I said, a good example how sometimes we can come up with solutions specific for what the contractor needs. So, just to touch on a bit of product selection, really. If you look through any of our website or our literature, you see that we've not actually got hundreds and hundreds of different products. We've got quite a small range of products. The only thing that tends to sort of differ between one to the others, different aggregate size, which could offer different strengths and finishes, different amounts of retardant, which is different setting times. So we've got products that are suitable for most different applications by only sort of altering those ingredients. But what you tend to find is the majority of products are multi-use products. They're all suitable for a range of different applications as well. It's why there's not as many on there. But with our new website that we updated sort of beginning of last year, what you can actually do is you can filter products by application method, by approvals, by size, whatever you're looking for, similar to shopping for clothes, filter by brand or by color, or whatever it may be, and filter down to the products which might be suitable for the application that you're looking for. So a really, really useful tool if you are looking to use one of the products and trying to find out which one's going to be the most suitable for the project that you're working on. So just a bit of section on sustainability then, and then we've got a bit of summary to finish off, and then all the time to some questions. So carbon footprint, I've mentioned this a couple of times, natural cement is around 30% lower than that of a modern Portland cement. You can tell from a lot of our literature, a lot of our branding, everything's green. It's quite a big thing for us. Quite proud that we're a sustainable company. Straight away, just purely doing on the production figures, you've got around a 30% reduction in carbon footprint as opposed to modern Portland cements. But what we tend to find was, especially in the last sort of 3 or 4, 5 years, obviously this is getting bigger and bigger for everyone. We've sort of banged the drum that we had our products are more environmentally friendly than others. Then people are sort of looking for much more now in-depth information as opposed to the specific carbon footprints and get the materials to site. What's going to happen to it in 100 years, and also what do we do as a company to be more sustainable as well. So as well as having a lower carbon footprint, and obviously not using chemical additives in the products, we've also been working with a company called Carbon Neutral Britain to offset our carbon emissions even further. But we've actually become a carbon neutral company within the last sort of 3 or 4 months. That's been sorted. So like I said, that's a few different carbon offsetting schemes. We've also been awarded ISO 14001 for environmental management procedures that we've put in place, reducing things around the office, etc. All the packaging is fully recyclable, and things like that as well, contributing to, like I said, to being a more sustainable company. You can go onto our website. You can download our environmental product declaration, which gives you all the exact facts and figures for the carbon footprint, the carbon emissions of the materials during production. And we're now actually in the process working with Carbon Neutral Britain to actually calculate the carbon footprint for every bag of material that's sort of giving the material to site, transport, like I said, installation, and then what's going to happen to the material when we take it out in 100 years or whatever as well. So just to give you an example of some of the sort of clients and projects that we get involved with. So the materials are really from anyone from a one-man band, a contractor working on a domestic property, doing a little bit of damp work, going to get a couple of bags from Travis Perkins, all the way up to some of the sort of biggest civil engineering companies that you can see on this list. We've supplied some prestigious projects. We've supplied materials for Crossrail and Thames Tideway fairly recently, just to name a couple. But you can see a lot of the companies on this list. A lot of them are water and rail based. It's not that we're limited to these. It's just that I find that a lot of applications in those areas are usually time critical. You've got to get them done fairly quickly. If you're in the water industry and you've got a reservoir out of service, it might be supplying however many thousands of properties you want to get back up and running as quickly as possible. Similarly, if you're carrying out repairs on the underground, you've got very, very limited working windows to get things back into service. So like I said, the lend themselves well really to natural cement products. But somebody then to finish off, and then hopefully see if anyone's got any questions. So the products are proven; they've been around for almost 200 years. They've got 200 years of history of being used successfully. So it's not a new technology, but I still feel it still outperforms a lot of modern alternatives. We've got a versatile range, suitable for a range of different applications. Like I said, a lot of the products are multi-use products. They're both user and environmentally friendly. I've run through the environmental benefits in quite a lot of detail, but generally in terms of the user, in terms of the guys that are actually carrying out the works, they're very, very straightforward products to use. Mix powdered water for 2 minutes and then apply it. They're useful for anywhere where time's limited. Hopefully I've reiterated that enough. I know I've mentioned it enough times. Anywhere where you want to get something done quickly or in adverse conditions. So whether that be cold weather, wet weather, all the areas which are probably not very nice for working in, the materials are going to be useful for keeping projects moving in those scenarios. They can save a considerable amount of time and money just by doing things so much quicker than a lot of alternative products. And lastly, they're approved by major companies in the UK and internationally as well. So thank you. Thanks everybody for your time this morning. If anybody's got any questions, please feel free to fire away and I will try and answer them the best I can.
Thank you, Jack. We have a few questions. It was mentioned that natural cement has excellent adhesion and waterproofing properties. I would like to ask what reference materials are which natural cement is compared to.
Sorry, can you repeat that question?
It was mentioned that
Sound a little
natural
bit.
cement has excellent adhesion and waterproofing properties. I would
Yeah.
like to ask what reference materials at which natural cement is compared to.
Compared to which natural cement product? It's not really clear.
Um,
Is it?
I'm not too sure about that one. We'll skip that one. Is natural cement more expensive than other types of cement?
Yes.
Okay.
Yeah. So if you compare sort of like for like materials with the application the product's used for, it's not very expensive at all. If you compare it to, I don't know, going to Travis Perkins and getting a bag of Blue Circle cement for £7 or £8 or whatever it is, then yeah, it's going to be a lot more expensive. But if you compare it to like for like products for the applications it's used for, as I mentioned, concrete repairs, waterproofing, grouting, a lot of those sort of specialist products, the material is quite comparable in cost, if not cheaper in a lot of instances. And if you filter in the fact that actually you're doing things much quicker, all of a sudden it becomes a lot cheaper in a lot of areas if you're looking at sort of cost in use. So yeah, if you're comparing like for like, it's not massively expensive at all now.
Thank you. And the last one, is a bonding agent required when repairing an existing artificial cement structure with natural cement?
Depending on the surface, if it's got a nice rough surface to give it a mechanical key, which usually if it's an existing structure and it's got damage or something, all you need to usually is apply water and then apply it straight to it. If it was a smooth concrete surface, then we'd usually recommend sort of scabbling it and preparing it and damp it down, then applying it rather than using a bonding agent if possible.
Yeah. Can the cement be mixed with most sand types?
Yes, it can. The majority of products that we supply already have aggregate and sand pre-blended rather than taking that rather than having to do that on site. But yes, if need be, it could be.
Okay. What treatment of steel is needed prior to the application, i.e. corroded R-bar?
Yeah. So any existing reinforcement, as long as it's still structurally sound, all we'd usually recommend doing is cleaning it down, removing any rust, making sure it's fully encapsulated in the natural cement product, so you broke behind it to whatever minimum thickness it was. And if you did all those things, you wouldn't need to use any additional treatment to prevent it from corroding any further. Obviously, if it's totally corroded, it need to be replaced. That'd be a structural issue. But if you look on our website, if you click on the product literature, you can see the application instructions. There's a few videos on there as well, which will explain that in a bit more detail too.
So that was our last question. So thank you, Jack, for the presentation, and thank everyone who has joined us this morning. Just to remind you that this session has been recorded and will be uploaded to our YouTube channel soon, which can be shared with your colleagues. And with that, I'll wrap up. Thank you again for your time, and we'll hopefully see you online next month.
Thank you. Thanks, everybody.